For x-axis symmetry, you'll see a graph that can fold over itself across the x-axis. The other thing that you'll notice is if you make a chart, you'll see that if you input the x values, or I'm sorry, if you input the y values that are opposite, you'll come out with the same x value. It seems a little backwards, but it works that way with the x-axis. If you take a look, if the y values are opposites, we come up with the same x value. That's how you get the symmetry about the x-axis. It's a little difficult to use a graphing calculator on this because if it exhibits x-axis symmetry, then the equation that you have isn't a function, and your calculator can graph functions pretty easily but not non-functions. So let me give you an example of an algebraic proof that you can do rather than looking at a calculator. And the proof is if you let y equal negative y and then simplify it and then get the same equation back, you have x-axis symmetry. Now, the equation can be an equivalent as well, but if you get the same one or an equivalent one back, you have x-axis symmetry. So, for example, a problem here, if I have xy squared minus 3x equals 12. Okay, and if I want to run this test to see if it exhibits x-axis symmetry, the thing I can do is let all y's equal negative y in the problem. And again, the reason you're doing that is if you take a look at the y coordinate of these points, they're opposites. All right. And then if I come back to the same equation, or if I get the same x value out, then I know that it had x-axis symmetry. When you square a negative, it becomes positive times y squared is going to be positive y squared. And you do get the same equation back that you started with. If you notice, I said that this is kind of a hard one to plot because you'd have to solve for y if you're going to use a graphing calculator. And to do that, you can, we're going to have xy squared equals add 3x to both sides of the equation, and then divide by x. You know, when you go into your equation editor, it's just y equals, not y squared. So you'd have to take the square root to both sides of the equation in order to solve for y. But when you do that, remember, you're also going to have to include a plus or minus symbol on the other side. This is where I'm saying it gets a little complicated in terms of graphing, because you actually have to graph two separate equations. Y equals the positive of this square root, 3x plus 12 divided by x. And then you have to also do the negative of that square root. And then when you plot both of those equations, you'll see that the picture does exhibit that x-axis symmetry.